God, I started. Okay, so the today what we will see, we will see the different approach how to create a thread, and then we will compare what is the best approach by using thread class or different one. Okay, so let me create a package. So runnable demo RUNNABLE com dot thread dot runnable. This is the package name, and runnable demo, this is a class name.
Okay.
Okay, now right. Generally how we are creating a thread, first we are taking a class and we are extending that class with thread, right?
Yeah.
Okay, that is the one. Okay, now also what I will do, class my thread. So this is a simple class I have created. So in the second approach, instead of taking thread, I will take an interface called runnable interface.
Yeah.
Runnable is an interface and it is available in java.lang package. Okay.
Okay.
Okay, this is an interface, so we have to implement the methods whatever it is there inside the runnable class, sorry, interface. So inside the runnable interface there is a method called run.
Yeah.
So here, right, sorry, so here we need to write the main task what you want to do by using this thread. So let's suppose I want to print numbers from 1 to 10. So this is my task. Okay, along with that number I want to print the current thread name plus I. So this is the way to get the current thread name. This, I mean, last time we have already discussed, right? Thread dot current thread dot get name plus I. So this is the way to create the thread by using some different approach instead of by using thread class. So right now I'm not extending any thread class here, right?
Yeah.
So basically this is some different approach. Okay, let me, how to call this thread, how to start this thread. So that purpose what I had to do, I had to create an object for thread class. Thread th1 equal to new thread. Okay, so this is the second point, and as part of this thread constructor, right, I need to pass my thread object. My thread, my t1 equal to new my thread, and I need to pass here mt1. Okay, now so far it is good, right? So I created my thread object and thread object, and my thread object passed as part of constructor of thread class. Now I need to start my thread dot start. Done. Now thread is started.
Yeah.
Now let me run it. Yes, now go and see the results. So thread is started and it is displaying. Thread name is my thread -0 and 0 1 2 3 5 9 till 9 it is printing, right?
Yeah.
This is good, right? Okay, now what I want to do, I want to create another thread and I want to print the same numbers. So how to create another thread? So for that purpose what you have to do, you have to create another thread object.
Yeah.
And you have to call the start method. So let me write here 2, here also 2. So 2 threads now. This is one thread and this is another thread. So these two threads are calling same my thread function.
Yeah.
So this is one, this is the difference between that previous approach what we did by extending the thread class, and this one is implementing the runnable interface.
Right.
Now let me run it and we will see the difference. So now two threads are created. See there, thread 1, thread 0, after that thread 1.
Yes.
Two threads are created and it's running and it's giving the output as a 1 to 9. This is clear, right?
Thread hyphen is actually the by default.
Which one you are telling? Thread hyphen.
Yeah. Thread
Yes.
hyphen.
Oh, that naming conversion, right? So let's suppose if you are not giving any name to your thread, so thread will give JVM will give naming conversion as thread hyphen 0. It will start from 0, 1, 2, 3, 4, 5 like that.
Okay.
If at all if you want to change the name, you have to use the thread dot set name. Then you
Yeah.
can, so that will give your own name. Let's suppose, let me give that one. So let's suppose I want to change this thread name. So what I have to do, set name. So
Set
I'm
name.
giving name as a first thread.
Okay.
Now it will not display thread hyphen 0. It will display first thread colon after that.
Okay.
So here I want to give to 2. Instead of first I want to give
Second.
second. See there, now it's not displaying, right?
Oh yeah. Right.
First thread, second thread. Okay,
Yeah.
this is the way to create a thread by using a different approach. The difference is previously we are using extending thread class, right?
Yeah.
So inside the thread class there is so many fields is there, so many methods is there. So if you extend any class, right, what will happen? Whatever it is there inside the thread class, everything will be coming to
In
your
my
class.
class.
So then the object will become huge, right?
Yeah.
So so that is the disadvantage of by using thread class. Okay, but whenever you are using runnable interface, right? So did you see that inside the runnable interface? Let me open it and we will see how many things is there. So there is nothing is there inside the runnable interface. Only one method is there.
Yeah.
So it's a light object, but by using thread class, it's a heavyweight object.
Yeah. Got it.
So this is one of the basic difference between thread class and runnable interface.
Yeah.
You got it right?
Yeah.
Yeah. Now we will see some other topic called some synchronization. This is a little bit interest and important. Okay, let me create synchronization demo. Okay, now what I want to do, I want to create a class called print numbers.
Okay.
So this is a simple class. Okay, so inside that public void print my number, print my number. Okay, so this is a method. So inside that what I want to do, it will take a number, integer I, sorry I, and after that I want to repeat that numbers for, I want to print it for I equal to 1, I less than or equal to 10, I
Yep.
plus plus. Okay,
Yeah.
simple. So after that I want to display the number.
Yeah.
Thread, I want to display along with thread name also, thread dot current thread dot get name plus. So I want to give the input. Okay, I star.
All.
So let me keep in bracket. This one I need to declare as int. Now it is fine, right? So I'm taking some number as a input and I'm printing the numbers from 1 to 10. Also I'm doing multiply. Okay, it is
Okay.
clear. So
Yeah.
this is a simple operation. So let me create an object, print p equal to new print numbers. So how to call that method? P dot,
P dot.
and I had to pass some 10. Now it will display 10, 20, 30, 100, something like that. Let me run it. So displaying thread name is main thread, displaying 10, 20, 30, 40, 50, 60 like that. This is clear, right?
Yes.
Okay. Now what I want to do, now it is calling from main thread. So name is, you did see there, main.
Yeah.
Now what I want to do, I want to create my own thread, two threads.
Okay.
Class um, THREAD one, thread one extends thread. So this is simple thread, right? So I had to
Yeah.
override the run method.
Yeah.
And after that, what I had to do, inside the run method, I want to call. So this is the one simple thread one, right? So from this thread, I want to call this method. From
Yeah.
this thread, I don't want to call from main thread. I want to call it from the thread one. I want to print the numbers. Okay.
Okay.
Okay. Now we need to create an object and we need to pass to this thread. So we should not create an object here. So you create one object and pass that one object to all the threads. So like that, let me create a constructor, and inside the constructor, what I want to do, I want to create an object. Okay, fine. And let me sign. So here what I did, I created a constructor, and that constructor augmented with print numbers, and I'm assigning that value to print numbers. Okay. Now whenever I'm creating an object for thread 1, now I don't want to call this one from thread 1 t1 equal to new
Thread.
thread 1, and b I had to pass, right? After that,
Yeah.
what I had to do, t1 dot
Dot. Get
start.
start.
So my thread will start, right?
Yeah.
Okay, now what I want to, I want to create another thread also. Just copy same as it is, and here instead of thread 1 I had to go thread 2, t2. That is fine. Okay. Now from thread 1 I want to print the numbers from 1, 2, 3, 4, 5. So factor I had given 1, and from thread 2 I want to print numbers from 10, 20 like that. So I had given a factor as a 10.
Okay.
Okay. Now let me start thread 2 also. I had to create same object again. I had to give here t2, t2, t2. Okay, now let me basically two threads I created, right?
Yeah.
Two threads, and they are sharing same object p. Okay,
Yeah.
and
Yeah.
they are trying to access the print numbers.
Yes.
See there, so they are trying to access the print numbers from both of the threads at a time.
Yeah.
Okay, now let me run it and we will see the results. And see there, sometime thread 0 is printing. Okay, now let me run it again. Okay, now what I want to do here, it's difficult to see. Let me give some 100. Yeah, now I'm trying to print the numbers from 1 to 100. Okay, let me run it and we'll see the difference. 200 or Did you see there? Sometime
Yes.
thread 1 printing and sometime thread 0 is printing. So you
Zero.
are getting output as a mixed.
Mixed. Right.
Basically, both threads are running parallelly here.
Yes.
Correct, right? That's
Yeah.
what you will see, both outputs, thread 1 output and thread 0 output.
Yes.
So how to control this one? How to stop this one? First, thread 0 should execute. After that, thread 1 should execute.
Right.
Always. So that's what my intention. Okay. So now instead of printing the number as it is, I want to wait for 1 second, 1 second delay. Let me print the numbers 1 to 10 and let me wait for delay. Thread dot sleep. So this one we have already saw, right?
Yeah.
I'm giving 1000 milliseconds means 1 second.
1 second.
So this is a checked exception, sleep method. So I had to throw the interrupted exception, and again I had to, here also I need to throw the, or else I need to provide try catch
Yeah.
for checked exception. So far it is good, right?
Yeah.
Okay, now let me run it and we will see the results. And see that thread 0, thread 1 both are printing parallelly.
Yeah.
But I don't want to print both together. I want to print, I'm expecting the results first thread 0. After that, I'm expecting the results from thread 1. But now both are giving results parallelly.
Yes.
So to avoid this situation, so I had to make this thread as a
Yes.
synchronized. Okay. Now let me run it and we will see the results. See there, now how many threads are running at a time?
At a time, actually two, but everybody following serial. First,
Correct. Now first thread, now thread 1 is starting.
actually, the one is running.
Correct. So now you can run n number of times. Always it will start only one thread at a time, either thread 1 or thread 0 or thread 1, only one thread at a time. So thread 1 will never start until thread 0 will complete, then only thread 1 will start.
Yeah.
If you remove the synchronization, let me run it by removing and we'll see the results. Just now I removed synchronization for that method. See there, now thread 0, thread 1, thread 0, thread 1. Okay.
Yeah.
So this is the advantage of synchronization. So now you understood, right? What is the difference between synchronized method and non-synchronized method?
Right.
And I told you, right, when I was explaining the string buffer and string builder.
Yeah.
So string buffer is not synchronized, string builder is synchronized, I said.
Right.
As part of append method, you will see the synchronized keyword.
Yeah.
String buffer having a method called append, and inside that method, as part of that method, you will see this synchronized keyword. So this is the advantage of adding the synchronized keyword for the append method. So at any point of time, only one thread can able to access and they can able to add the content.
Right.
Okay. And now this is clear, right? Now what I want to do, I want to do some other change, static synchronization. Let me create another class. This is clear, right?
Yes.
Okay. Now let me go to some other example. Okay, let me clear this one. Okay, what I will do, I will copy the same example as it is. I will
Okay.
change it. Okay, now our threads are ready. So now, so far, right, how we are accessing our print numbers method, we are creating an object and we are accessing, right?
Yeah.
Okay, now okay, let me copy the main method also. So this is the one where we are calling and we are accessing the print numbers method. So now what I want to do, I don't want to create an object for print numbers method. Basically I don't want to pass it.
Okay.
So I don't want to pass it. So if I don't want to pass it, then what I had to do, I had to remove all this constructor, all this.
Yeah.
So let me remove it here also. Let me remove it here also. So here, right, then how can I call this print numbers method? So now there is no object. So what is the other way to call a method? I had to make this method as a
Static.
static. Then only I can able to static, right? So here instead of what I had to use print numbers dot static. Now I can able to, by using print number static, I can able to call that method directly.
Yeah.
Now so far it is good. Remove it, remove it. Everything is there in our class only. Remove it. Now let me run it and let me remove it first static. Sorry, synchronize it and let me run it and we will see the results. So both threads are running. Now there is no synchronized. So both threads are running. It's giving the results, right?
Right.
Okay. Now let me add the synchronized and let me run it. Thread 1 is starting first. See, any one thread at a time. It's not, there is no guarantee thread 1 or thread 0, but one thread at a time.
Okay.
That's all. So now this is clear, right?
Yeah.
So the advantage of static synchronization means you no need to use any object, but still
Right.
synchronization will work. So did I'm creating any, I'm not creating any object for print numbers, right?
Yeah.
So this is the difference between static synchronization and non-static synchronization.
Right.
Okay. Now let me go for some other example. Okay. Now let me create a class. Okay. Let me copy the same example as it is, the previous one, and I will do the change for the same one.
Okay.
So these two examples are clear, right?
Yes.
Static synchronization and non-static synchronization.
Right.
Okay. So now, right, let me add something here. So say for instance, in this method, say for some 100 lines is there.
Yep.
Okay, just assume 100 lines is there. Okay, the main, these are the critical part, 4 lines. Assume just remaining lines are not critical, so it can execute parallelly also, there is no issue. So how to block only a particular number of lines? I want to execute only these threads, only one thread at a time. I don't want to keep synchronized for all the method. So why? Because if you keep synchronized for entire method, what will happen? The other threads not able to access entire thread. Got it right? So they have to wait for lock. Okay, you got it, Mustafa?
Yes.
So if you keep synchronized, means this entire method no one can able to access, only one thread at a time. So if I keep synchronized only for these lines, so rest of the lines can able to access.
Yep.
So I want to block only this particular number of lines. So how to block only this particular number of lines instead of blocking entire thread? So let
Okay.
me remove it and keep here, keep it here. And now, see, now there is no synchronizer here. So synchronizer is there for a particular block. Okay, now let me run it and we will see the difference. Okay, now let me run and we will see the difference. There is some errors is there. Did you see there? Thread 0 started and it's giving the results. Now there is no synchronized here at the method level. The synchronized is level at a particular logic level.
Right.
Okay, now what is the advantage? Let's suppose, say for instance, I want to write here a system mode call thread dot current thread dot get name started. So this, for this statement synchronization is not required, so that's what I didn't keep inside synchronize block. Okay,
Okay.
so main critical operation is for loop. The system out or any other thing is not a critical, so I don't want to block this statement.
Okay.
Okay, now let me run it and we will see the results. Did you see there? Both thread 0 and thread 1 are printing together, but final results we are getting only from thread 0.
Zero.
Why? Because this is not a synchronized statement, so both threads can able to access this statement, but this one is synchronized, only one at a time. Got it right now?
Yes.
Advantage of synchronized block and synchronized method and static and non-static.
Right.
So this is the advantage of synchronized keyword. So that by using synchronized keyword, so multiple thread cannot not able to access one method at a time. So they have to wait for lock. So how that is happening? Let's suppose this is a print number is a method. So whenever one thread is trying to access this method, it will go inside and it will block the method, it will lock the method. Other threads, they are not able to access it. Why? Because key is there with the first thread, key is there with first thread. So once the execution is done, then thread 1 will come out from this method and it will hand over the key to the next thread.
Okay.
Okay, this is the way we can able to block the multiple threads.
Yeah.
Okay,
Yeah.
this is clear, right?
Yeah.
Okay, okay, now the next one we will see the different keyword called thread group. One second. Hello, this is clear, right, Mustafa? I mean, the advantage of synchronization, this is very important. If you go for interview, they will ask a number of questions only for the synchronization.
Yeah.
So you understood, right? The you can practice yourself more examples by changing here and there so that you will get more idea.
Yeah, actually, I got it.
Uh,
Hopefully, I'll see
yes,
tomorrow. And
yes, yeah. You can practice these examples, and so that you will get more idea. I mean, you can remove something and you can add something so that you will get some errors or exceptions, so that you can able to do more.
yeah,
Okay,
yeah,
and the next one is synchronization static public class. The next one is will give. So far, right, how we are creating multiple threads, and multiple threads we are creating, and we are running, we are starting them, and we are executing them, right?
yeah.
Okay, let's suppose say for instance you created three threads, and if you want to know how many threads are active stage and how many threads are dead stage,
Okay,
so we don't have any controlling group, we don't have any master thread.
right.
So all are independent threads, and every time they are executing and they are running and they are giving the results. So okay, so
Yeah,
before going to that, so I want to give some join. So let me write package com dot join dot demo join demo. So this is a simple class join demo.
yeah.
Okay, so let me, there is a keyword called join, so we'll see that uh, keyword first. After that we will go for thread group or thread super thread or whatever.
Okay,
Okay, let me run class. Okay, let me copy the print numbers method as it is. So this is a simple class, let me copy it. So this is a simple class, right? So what it will do, it is printing the numbers. Okay,
yes.
now what I want to do, I want to call this method from my thread. So let me copy one thread class. This is one simple thread, let me copy it. Okay, now thread, I want to create an object for my thread.
Okay,
How to create thread1 t1 equal to new
new thread one.
thread1, and p I want to pass it from the t1 dot start. After that I want to say thread execution is completed.
Yes,
It is clear, right? I
yeah,
want to create print number object here, I want to pass it. So instead I can pass directly, right? New.
yeah,
This is also similar, right? Instead of creating object and passing, so I can create object directly here and I can able to pass it.
yes,
So now for inside my main method, what I'm doing, first I'm creating a thread object, I'm after that I'm calling it, right?
yeah,
Okay, once the thread execution is done, then I'm printing thread execution is completed, right?
yeah.
Okay, now let me run it and we will see the results. See there, thread is started. Before starting the thread only, I'm displaying method as a thread execution is completed.
Yes.
But that is wrong, right? So before completing the thread, I'm displaying message as a
Thread
thread,
execution is completed.
thread execution is completed. So this is wrong, right?
Yeah.
So so now two threads are executing here. One is main thread, another is thread one.
Mm,
So how to control two threads? So my intention is if thread one is completed, then only I want to display this message.
right.
So I don't want to display immediately. So now it is displaying immediately, right?
Yes.
So how to stop this one? So for that purpose, there is a keyword called t dot join. Now let me run it. So t dot join, it is a checked exception type. So it is throwing an exception called interrupt exception. So either I had to provide try catch or else I had to throw back.
Mm,
So I'm rethrowing the exception to the caller.
yeah.
So now run me. Now just let me run it. Did you see there now? First thread 1 is executing, right?
Yeah.
Thread 1 still it is executing. Thread 1 still it is executing. After that, what I am displaying,
Thread execution is completed.
this is perfect, right?
Yeah.
So what is the advantage of this join keyword? So the use of join keyword, right? Whenever you are calling join from any thread,
Yeah.
so whenever you are calling join from any thread, what will happen? The current thread. This is my current thread. Main thread is current thread, right? So it will block. It will block from here, and it will not execute rest of the lines. So it will give high priority to the current thread one. So once thread 1 is execution is completed, then only main thread will execute.
Right.
So that's what we can able, by using this keyword we can able to control two threads. If there is no, suppose if you comment this join method, right? So
Yeah.
the both thread will execute parallelly, and you will see the results. See, it started giving the results starting only.
Yeah.
So if you enable this one, you will get results. Once the thread 0 is execution is completed, then only you will see the results. So this is the advantage of join keyword. Okay.
Yeah.
Now let me go back. So this is clear. Join keyword is clear.
Yeah.
This is clear, right? Join keyword.
Yes.
Okay. Now let me give some other example. Okay. Now I want to give some other example called thread group. So far, right? What we are doing every time we are creating a thread. Let me create two threads. Okay, let me copy the two threads whatever I have created previously, and we will use that threads for our example purpose. So now what I did here, I created two threads. Okay, I
Yeah.
created two threads, and I don't want to pass the object. I want to call this. I want to call this method by using directly class name. So for that purpose, what I had to keep here, static, right? Static. This is perfect. This is over here. What I had to do. This is perfect. Okay, now this is fine. So there is a rule. There is a rule inside the static block or static method. We should not use this keyword. So for that purpose, what I am doing, I'm copying. I'm keeping this entire method as a static. I don't want to keep here static block. Why? Because there is a rule inside the static block. You should not use any this keyword. And now what I want to do, I want to create an object for these thread classes, and I want to start my threads.
Okay.
Thread 1 t1 equal to new thread 1 t1 dot start. So t1 dot start, it will start thread 1. So two threads will start now. Let me run it. So now two threads are in active stage, right?
Yeah.
Okay, now what I want to know, I want to know how many threads are completed, how many threads are not completed. So for that purpose, right, so there is a call, there is a thread group tg equal to new thread group. Okay, so this is a thread group. So now your thread group is ready, so we have to register this thread tg. So let me cut it, paste it down. Okay, let me open this thread class. So inside the thread I want to see how many. Yes, thread group, yes. So whenever you are using the, whenever you are trying to use the what is a thread group, right, so that thread must be implemented with runnable interface. So here instead of thread I had to use the runnable interface. So let me change it, I will explain you later. So our threads are ready. So here instead of thread 1 I had to use thread thread thread. So here I had to pass my thread 1. Let me create it. Thread 1 t1 equal to new thread 1. So here I had to pass tt1. Perfect. Now I want to pass this to for t2 as well. Now let me go back, and it is not required. Let me clear it, and now I will explain you. So so first I created a thread group object. Okay, so this is part of java.lang package, and inside that thread I created two threads, thread 1 and thread 2. So these threads are implemented by using runnable interface.
Okay.
Okay, so inside the thread class there is there is a constructor which is having two arguments. First one is thread group and second one is runnable thread object. Okay,
Okay.
now two threads I created, t1 and t2. Okay, now I want to start the threads and I want to display the, I want to check active count.
Okay.
So how many threads are currently inactive? So now let me see how many threads got created and how many are active. Did you see there? Active count is 2. How many threads are inactive now? Two
Two.
threads, right? Two threads are started. Two threads it is telling, two are active. So if you create three threads, it will say three threads are active.
Okay.
So now let me create another thread called T3. And now also we have to register all this thread with the thread group. Did you see that? T3 is common, TG is common, right? So
Yeah.
all the threads are registered with the thread group, and from that thread group I'm trying to get the active count. Now let me run it and we will see the active count. So do you see that how many, what is the active count?
Three.
3. And 3 threads are trying to execute it. At any point of time, if you have this thread group object, so you can able to get the active count. Also there is so many other methods also is there. If you want to use, you can use it. See their active group count and get name, get hash code, toString, get parent. So these are the some useful methods
Okay.
from the thread group. So I explained you one method, so which will give you the active count. So how many threads are active? So how many threads are expired? So by using this thread, you can able to, sorry, by using this thread group, you can able to monitor the child threads. So this is the advantage of thread group. If you have n number of threads, so if you want to know at any point of time how many threads execution is completed, how many threads are not completed, then you can use this one, tg dot active count. It will give you the number of threads are in active stage.
Okay.
So this is the advantage of thread group. So this is about brief introduction about threads.
Okay.
Okay, and tomorrow we will see some other, topic might be some cloning, I guess.
Okay.
Cloning or some JDK5 or 8 features like generics, enums, such kind of things.
Okay.
Okay, tomorrow we will meet same time.
Okay.
Okay,
Yeah.
if you can have a look, and if you have any doubts, and we will discuss tomorrow.
Yeah. Today,
Okay.
actually, I'll look it and then tomorrow.
Yeah, fine, no problem. I will upload this video today itself so that you can visit the video again, and if you have any questions, we will discuss tomorrow.
Okay. Yeah.
Okay,
Thank
yeah, fine, yeah, thanks.
you.
Good night.